Good evening. My name is Mary Lazinski. I am Inform's Creative Director. On behalf of the Inform Southeastern Michigan chapter, I'd like to welcome you to our webinar this evening, From Pandemic Disruption to Global Supply Chain Recovery, featuring David Simchi-Levy of MIT. We would like to start with a couple of housekeeping notes. We will be using the Q&A box for questions as opposed to the chat feature this evening. Our moderators will ask them at the end of the presentation. There will also be a poll during the webinar, and in order to participate, you will need to turn off your pop-up blocker for this particular site, or you will be unable to see the poll. We will be recording this presentation this evening, and we'll share the link afterwards. I'd like to introduce Oleg Gushikin, our moderator for this evening. Dr. Gushikin is a technical leader at Ford Motor Company, Global Data Insights and Analytics, where he leads projects in supply chain, manufacturing, and connected vehicle analytics. Together with Professor David Simchi-Levy, he is the recipient of Inform's Wagner Prize for their joint work in supply chain risk analysis. Oleg?
Thank you, Mary. It is our honor to host MIT Professor David Simchi-Levy, who is a world-renowned expert in supply chain and specifically in supply chain risk. I don't think there is a need for a long introduction, as most of us in Informs and supply chain community know Professor Simchi-Levy well. I only would like to mention our prior and current work with David on supply chain risk models. About 7 years ago, we started Ford MIT Alliance project with Professor Simchi-Levy and his team, where we develop efficient risk model and proactive tool for Ford Motor Company to analyze the risk in our supply chain. This is a project for which we receive Inform's Daniel Wagner Prize. We use this tool at Ford over the years to analyze the impact of suppliers in the areas around the world in case of natural disasters and political unrest. This analysis helped our purchasing and material planning and logistics to create mitigation plans. In fact, we use these models to analyze the impact of our China supply base earlier this year at the beginning of pandemic. Currently, this original tool is one of the key foundations we use to develop the models for recovery planning. We stay in close contact with David to get his insights and latest research results to help us build those models. We believe the scope of these models go far beyond the automotive industry and can benefit supply chains across multiple domains, including government and healthcare. And we're grateful to David for sharing his insights with a broad audience. And with that, I would like to welcome Professor David Simchi-Levy.
Thank you, Oleg. Thank you, Mary. Good evening or good morning, everyone, depending on where you are. Let me start with a comment. I hope everybody is safe and healthy and getting used to the new normal of remote work. Here is the talk outline. I'm going to start with a short introduction, then introduce the risk exposure model that was developed in 2013 and 2014 after disruptions like the tsunami in Japan. This model, the concept, and the implementation at Ford are described in the Harvard Business Review article that we published around that time. Some of the key ideas are also described in my book, Operations Rules. Once we understand the concept and the key ideas, we will try to apply them for a recovery plan. And then I will summarize with analysis of the impact. At the end of this presentation, there is an appendix that include a few analytical models that one can develop and apply. I want to emphasize that these analytical models we think are important, but many of the concepts that I will introduce here do not require sophisticated optimization technologies and models. You can apply them by using spreadsheet type of analysis, and in fact, I'll talk about that throughout this presentation. So let me start with a brief introduction and a good way to start this presentation is to reflect on the last 10 years. In the last 10 years, we have seen significant increase in supply chain risk, and this is in part due to successful implementation of strategies like lean, like outsourcing, and like offshoring. For instance, what does lean mean? Lean implies low level of inventory. Low level of inventory suggests that if there is a disruption, the supply chain will not be able to match supply with demand. Outsourcing and offshoring implies that the supply chain is geographically more diverse, as a result, exposed to all sorts of potential problems. And this was demonstrated throughout events like the tsunami in Japan or the flood in Thailand in 2011, or the volcano eruption in Iceland in 2010. And there are many case studies and examples describing companies who were able to effectively recover from this type of events. Of course, we can learn from these case studies, but the magnitude of the disruptions that we see today is completely different than the event I'm describing in this slide. Moving forward, it's appropriate to look just at the last 5 to 6 weeks. In the last week of February, I published a short article in Harvard Business Review together with Pierre Harren, who is a technology executive, where we started the article by applying, doing back of the envelope analysis using the concept that I'm going to describe here, and concluding that the peak of the impact of COVID-19 on global supply chain will happen in mid-March, forcing thousands of companies to shut down manufacturing facilities or reduce production significantly. And this is exactly what happened in mid-March. In mid-March, European automotive manufacturing companies, giants like Volkswagen, Renault, Peugeot, Fiat, all announced that they are shutting down manufacturing. And this is not only in Europe. This is also reported at the same time in North America. Major automotive manufacturing companies also stopped production. And this is not only in the automotive industry, this cascaded into many different industries. Of course, for most companies, there are multiple levels of challenges to think about. Right now, many executives are trying to find their way through these tough supply and demand challenges. In the long term, they need to prepare for a recovery that will surely arrive in the not too distant future. And of course, long term, I believe we will see significant supply chain restructuring and a move from low-cost supply chain strategies to strategies that balance between cost efficiencies and supply chain resiliency. Today, I am not going to talk about the right now. I'm not going to talk about the long term. Today, I'm going to focus on the short term and try to answer one question. How can the firm design a recovery plan given the huge uncertainties that we see both on the demand side and on the supply side? To get an insight into some of the challenges and some of the complexities, let's start by analyzing three different scenarios. The first one is what I call worst case. In the worst case, no cure is available for a long time, perhaps 18 months. We will need for a long time to maintain social distancing, significant impact on demand and supply, and we are likely to see in this process a large number of bankruptcies of mid-size, small-size suppliers and manufacturers, as well as probably of retailers. The best case scenario is a scenario where social distancing and testing allow North America and Europe to control and reduce the pandemic, and life is back to normal by the end of the second quarter. If this happens, one thing for sure, very quickly suppliers, manufacturers will start moving parts, components, inventory across the supply chain, huge pressure on logistics and in particular transportation capacity. I'll talk about that in the next few minutes. The most likely scenario is different. The most likely scenario is that peaks in various regions will happen at different time and the magnitude will be different. It's likely that we will see multiple waves. This implies that the pandemic effect will stretch beyond the second quarter. This implies that when you look at a supplier facility, it may be working up for a month and then down for the next month because of the peaks and valleys and because of the multiple waves that we will see during that period of time. This implies many challenges that we need to address. Let me enumerate some of them. The first is to understand the impact of supplier downtime on business performance. For example, estimate the backlog. Estimate how long can you match supply with demand from the inventories that you right now have, and when do you need to stop production? When do you need to expedite? And for how long you need to do that? The fact that peaks in different regions will happen at different time is certainly a challenge, but it's perhaps also an opportunity because we may be able to move resources from one region to another region to better match supply with demand. Here is an example. It's likely that we will need to reposition inventory in anticipation that certain region or certain facility will be under quarantine. We may need to identify creative ways to quickly reconfigure supply chain. I'll give some examples of this in case of suppliers going out of business. Some companies may need to address supply chain blocking. What are supply chain blocking? Supply chain blocking happens when downstream facilities cancel order for upstream facilities. This is right now happening for many manufacturers in Asia. Chinese manufacturers who in January and February under quarantine told their workers don't come to the office. Some of them are telling the worker today don't come to the office because many of the orders that they had before are all canceled by the client, by their customers in North America and in Europe. And finally, we need to estimate customer demand. For many companies, demand is declining dramatically, but this is not true across the board. In certain industries, for certain companies, we see significant increase in customer demand. So in order to get an insight into some of the concepts, some of the ideas that we have developed together with Ford when we developed the risk exposure model, let me introduce a model that give insight into what we are going to use in our recovery plan. Let me emphasize the objectives of the risk exposure model. The first was to identify exposure to risk associated with parts and suppliers. The second is to decide how to allocate resource effectively at time of disruption. And the last objective was all about developing mitigation strategies. Of course, when we developed this model, we were focusing on events such as the tsunami in Japan. There is a local disruption in one region that had an impact on many companies globally. Now we see, of course, a different magnitude and a cascading effect of the disruption, but some of the ideas, as you will see, can be helpful as we think about a recovery plan today. So to illustrate the approach, let's look at this simplified description of Ford's supply chain. On the left-hand side, I have Ford assembly facilities. You see here tier 1 suppliers, tier 2 suppliers, and so forth, and so on. I want to introduce a few concepts, but one important observation is that I'm starting with a supply chain mapping. I'll come back to that point in a few minutes. So here is the first concept that I want to introduce. It's a concept that we call time to recover. What is time to recover? Time to recover is a time it takes for a specific facility to recover to full functionality after a disruption. Take, for example, the chemical supplier. We collected data from the chemical supplier, and its time to recover turned out to be 2 weeks. In the case of the current pandemic, we have information about time to recover. Think about the automotive industry. There was a recent survey of suppliers in the automotive industry, about 3,600 suppliers in that industry. And these suppliers reported the following. 25% of them said that they will be back to full functionality by the end of April. That tells you the time to recovery is about 4 weeks. Another 25 to 30% said that they will be back to full functionality by the end of May. That tells you the time to recover is about 8 weeks. Similarly, if you have suppliers in Europe, for example, suppliers in Italy, and these suppliers are in a region where quarantine is until the end of April, then you know again, time to recover is about 4 weeks. And so in similar fashion, we populated information about time to recover by region and by suppliers. The second concept is what we call performance impact. What is performance impact? Performance impact is either financial impact or operational impact. Financial impact may be impact on forward revenue or impact on forward profit. Operational impact is impact on production. What is the amount of lost production? Because this translates into market share. And so you look at, for example, the chemical supplier or a group of suppliers, you know what time to recover is. You remove this supplier from the supply chain for the duration of time to recover, and you estimate, given the best allocation of the remaining resources, what is the impact on my revenue? In this case, we estimated the impact is about $400 million. And in a similar fashion, you calculate performance impact, and here I'm looking at one KPI, impact on revenue, associated with each supplier or a group of suppliers in different regions. And this gives me what we call risk exposure. This is the impact of disruption anywhere in the business on the performance of our company. This is the assembly facility and our ability to match supply with demand effectively. Importantly, I don't need to remove one plant or one facility or one supplier at a time. I may look at a group of suppliers, all are in the same region, and understand the performance impact during time to recover associated with quarantine in a specific region. Let me give an example that will illustrate some of the ideas that later on we will use from Ford data. So this is real data that we applied in 2014. What you see in this slide, bubbles represent a supplier, in fact, supplier site. On the Y coordinate, you see annual total spend at each supplier site. And on the X coordinate, I am demonstrating performance impact. And in particular here, we are showing impact on profit. Look at the supplier here at the top. This is clearly a strategic supplier. This is a supplier that Ford invests huge amount of money every year. It's clearly a risky supplier, but it's not the highest risk supplier. The highest risk suppliers are at the bottom right-hand side. Look at the one where my laser pointer is indicating. This is a supplier where total spend is very small, but if supply is disrupted, huge impact on supply chain performance, in this case, on profit. And this supplier, in this case, is associated with low-cost component. Each component may be 15 cents, but if supply is disrupted, you have to shut the production line. My point is that as we plan a recovery, we need not only to focus on strategic suppliers, we need to focus on suppliers across the entire supply chain, because risk may be hidden in unexpected places. Finally, before we switch to a recovery plan, I want to introduce another concept that will help us shape our recovery plan. Remember, I introduced before time to recover. I will remind you the definition of time to recover in a second. In addition, I want to introduce what I call time to survive. So let me start with time to recover. What is time to recover? Time to recover, as we said earlier, is a time for a specific facility or a group of facilities in a specific region in the supply chain until they come back to full functionality after a disruption. For example, if you have multiple suppliers in a certain region in Europe where quarantine is until the end of April, then you know time to recover is another 4 weeks. Once we know time to recover, we can estimate the impact of this recovery time on performance measure, like impact on profit, like impact on revenue, or production, or lost production. Time to survive is different. Time to survive is defined as the maximum time that a supply chain can match supply with demand after a node is disrupted, or after a group of nodes are disrupted. So you remove a node, a facility, or you remove multiple nodes, and you ask, how long can I match supply with demand without this node? It's not necessarily zero, because the pipeline is full with inventory, but we can estimate this KPI. Once we know time to survive, it can give us information on how long can we keep on matching supply with demand until we have to stop production. What should be the backlog level? And together with time to recover, it gives us information about the entire recovery plan. Let's illustrate this with the following observation. If time to recover is shorter than time to survive, supply is not disrupted because I have enough in the pipeline to match supply with demand until this facility is recovered. What about the reverse? If time to recover is greater than time to survive, I will need to shut down manufacturing facilities for the duration of the difference between time to recover and time to survive. So this gives an insight on what I need to do. Notice the star that I have next to shutdown plans, because I need to shut down plans when time to recover is greater than time to survive, unless I have a creative way to replace these suppliers. But if I don't, then this is the amount of time that we need to reduce production and shut down the facility. What about the situation when time to recover is equal to time to survive? If time to recover is equal to time to survive, I have no choice, but I need to expedite. Let me give an example. Suppose your supplier is in Asia, you typically ship over the ocean, it takes about 35 days. If time to recover is equal or almost equal to time to survive, I will need to expedite and ship by air, because if I ship over the ocean, by the time items arrive in my facilities in North America, I lost a lot of customer demand. And so looking at the difference between time to recover and time to survive give us an insight on the impact of this supplier or group of suppliers on my business. When should I shut down my manufacturing facilities, and when should I start operating it again? And when should I expedite, and perhaps how long should I expedite for? So let me summarize with key features captured in the risk exposure model. And remember, initially it was designed for a company like Ford, but this is a generic model that we have used in other industries, and I'll show you the industries in a few minutes. It captures a firm supply chain and production portfolio. It captures bill of material information. It captures volume and profit margin, pipeline inventory, and of course, time to recover by different scenarios. And because we remove a facility or a group of facilities during a disruption, we optimize the allocation of the remaining resources to maximize or to optimize a certain objective. Let me just mention that this model was initially, of course, developed together with and implemented at Ford. But then we have examples of companies in telecommunication, high-tech, pharmaceutical, and aerospace who have applied this model as well. As Oleg mentioned and Marie mentioned, in 2014, this model received the Wagner Award, and in 2015, and that's what I'm really proud of, it received Ford Engineering Excellence Award. There is a paper that was published not too long ago that illustrates how the UN has applied this model in developing countries. So let me pause here and ask Mary to share the two questions that we have for the poll, because it will, if everything goes well and we get enough data, it will give us an insight into some of the challenges that companies have in establishing their recovery plan. So let me pause here, Mary, and let you run the poll if we can.
Yes, David, the poll is launched. Thank you.
That's good. I don't see it, but hopefully everybody else can see it. Okay. Are we still receiving answers, Marie, or this is it?
This was it for now. I didn't want to pause you too long.
Perfect, perfect. So let me just take note of the numbers, and perfect. All right. So the first question that we asked in the poll was, have you mapped your supply chain? And the numbers are about half and half of, I believe 45% of you said yes, and 55% of you coming from companies said no, we don't have a good mapping of our supply chain. The second question is more challenging and critically important in this disruption. That question was, have you mapped your suppliers network? About 10% said yes, and 90% said no. So keep this information in mind as we think about the recovery process. With respect to your supply chain, about half of the companies said, yep, we mapped our supply chain, and the second half said we don't have a good supply chain mapping. With respect to supplier network, about 10% said we have a good understanding of our supplier network, and the remaining 90%, remember this number, 90% said we don't have a good mapping of our supplier network. Okay, so let's keep these numbers in mind and now talk about the recovery plan. And I want to highlight a 5-step plan for the recovery. The first step, as you saw in the risk exposure model, the first step requires mapping out the supply chain and estimating time to recover by scenario. I'm going to talk about each one of the steps later on, but I want to highlight an important requirement. If you have not done this so far, you need to do it immediately, because this is a critical part of any recovery process. The second step is, by each scenario, we want to estimate the demand and then assess performance impact. Remember our definition of performance impact associated with time to recover. The third step is all about determining how long we should shut down facilities or reduce manufacturing dramatically. And remember, this requires not only time to recover, this requires a good estimate of time to survive. It's the relationship between the two that give us an insight to step 3. Step 4 is all about the recovery. And the challenge here is to allocate the available or the remaining resources effectively among products. This may require, as you will see in a second, deciding that we are only focusing on a subset of our product because the resources are not there, or the demand is not there for many of the products that we produce to and sell in the market in normal time. And finally, using TTS and TTR, you want to determine when you need to expedite and for how long you will need to expedite. And you need to book capacity as soon as possible. And capacity, I mean logistic and transportation capacity, because once recovery starts, there will be very few resources available, and the cost of these resources will be extremely high. And so let's start with the first step. Remember our insight from the analysis of Ford supply chain. It's not enough to focus on strategic suppliers. Small suppliers, those that provide low-cost component, may be even more risky to the organization. That's the reason why this step, the first step, is all about supply chain mapping. This requires connecting with tier 1 suppliers. If you have not done that, I suggest that buyers in the company will be on the phone with tier 1 suppliers to identify their suppliers. You can also use technology companies that have databases on supply chain and companies participating in different supply chain, and that can help accelerate the process. Whatever you do, you need to do it immediately. The second step is analyzing each one of the scenarios. The first is about estimating demand. Most companies use statistical techniques. Some companies use, in addition to statistical techniques, machine learning and AI. But you want to complement this data with external data, this data and techniques with external data, such as information about China and South Korea recovery insight that allow you to better adjust your estimate of customer demand. I'm working with one company where we combine these data and technologies and analytics also with academic modeling that allow us to better estimate customer demand in different markets. Also, for each scenario, you want to understand and analyze the impact of disruption in different regions on various performance measures. Remember the performance measure I mentioned earlier, and identify which suppliers and which region in the network create the highest risk. As well, you want to estimate time to survive, because the entire recovery plan depends on these pieces of information: time to survive, time to recover, and performance measure. So in the third and the fourth steps, we take information about time to recover, and we identify how to best allocate resources to all the finished goods or to a subset of the finished goods that the company want to focus on to achieve a certain objective. Apply also time to recover and time to survive to determine when to shut a facility and for how long to shut the facility. And in particular, you want to take advantage of the fact that peaks in different regions will differ in time and will be different in magnitude. And so you may want to reposition inventory or move capacities. This probably is best done as part of a company S&OP process. The last step is apply this concept to identify how much and for how long the company need to expedite product or components or inventory. The sooner you reserve transportation capacity, not only the lower the cost is, the more likely it is that you will have capacity available for your use. So I'm emphasizing here a couple of important steps to focus on immediately. One is supply chain mapping. That's the starting point. The last step, reserving and booking transportation capacity, is also an important step to identify right now. Otherwise, there will be premium cost and shortage of transportation capacity to provide product to the market. In this process, we also want to consider some creative solution to address suppliers going down. Here are the obvious one: paying more for certain components from alternative suppliers, financially helping small or critical suppliers, changing bill of material or changing recipes or replacing materials if we can in order to overcome shortage in a certain component. The most creative one that I have seen is the last one, where an OEM share blueprints, design of certain critical component with suppliers who never produce this component that we are now trying to produce. But these suppliers can modify existing tools and machine and enable the production of the component, basically creating a community of suppliers that will focus on the missing component and will allow the supply chain to recover relatively quickly. Let me summarize with the impact. And I want to analyze or to highlight the impact from 3 points of view. From supply chain executives, not only you need to do the analysis multiple times to address different scenarios, but you will need to run it multiple times over different time periods, because you will get more information about customer demand and signals from affected regions. As I mentioned 2 examples, China and South Korea, and therefore you will be able to update demand estimate. You want also to take advantage of shifting peaks over time and book logistic capacity. From a business executive point of view, I want to highlight 2 elements. One is you need to decide on which product portfolio to focus on. Think about the automotive industry. The automotive industry is going to face significant decline in customer demand. There is no question about that. So maybe the opportunity is to shift production, to move to products that are highly likely will be in need for example, emergency vehicle. Also, executives should expect significant decline in many industries, not all, in sales and revenue. And it's obvious that we are going to see companies looking for cost-cutting measures everywhere in the business. And finally, I want to highlight from the consumer point of view, not only facing shortage and longer delivery time, but higher prices, and we are already seeing some signals of this type, and much smaller product variety. Let me just mention that we will make a PDF version of this presentation available in the appendix. If you're interested in optimization model, you will find 2 optimization models, one associated with time to recover, one associated with time to survive, with explanation of each one of the model. You can also see more insight about the Ford implementation that was reported in the Harvard Business Review article. Let me stop here and just mention and just say thank you to the Southeastern Michigan chapter of Inform for organizing this, and of course for Inform for helping us with all the logistics of this event. Thank you, and I am going to return the microphone, the virtual microphone, to Jason, who can pick some of the questions or all the questions from what you sent us.
Okay, thank you, David. There are some questions already on the Q&A, and also you can also ask questions freely on the Q&A, and I will pick some questions to ask Professor Semchilevy. The first question is that in the long term, how will supply chain strategies change, and what will be different by industries, such as pharmaceutical industry?
Very good. So as I mentioned earlier when I started this broadcast, I mentioned that I think in the long term we are going to see supply chain restructuring. Supply chain restructuring does not mean that everybody move completely out of China, but it means diversifying your supply chain to develop a more resilient supply chain strategy. Let me also highlight that this started happening even before the pandemic. Because of the US-China trade war, we have seen some companies restructuring their supply chain. And depending on the industry, you see different strategies. Let's start with fashion retailer, fashion designers and manufacturers. They started moving manufacturing activities from China to countries like Vietnam, Malaysia, Cambodia. These are low-cost countries, but they provide the ability to move manufacturing from one region to another. In high tech, we are going to see a different strategy. First of all, remember there is a significant supply infrastructure in China that is not going to be easy to move. So it will take some time. But when there are changes, I suspect that some of the changes will be to move some manufacturing facilities closer to market demand. For North America, this may be Mexico and Brazil. For Europe, it may be Eastern Europe. In pharmaceutical, this is a national security matter. You will likely see a change in strategy where companies try to diversify and make sure that they are able to respond in case of disruption. Yes. Any other question, Jason?
Okay, thank you. The next question is about how to build a resilient supply chain such that it can be recovered fast, or more generally, which technologies do you believe improve the supply chain resilience, such as within the next 5 years?
So I believe that resiliency requires the use of optimization technology. When you do it for the long term, you need to use optimization, like most companies are using optimization for network design. This will be, think about the next level of network design, which is not just the design of the network, but design of a network that is finding the right balance between low cost and resiliency. And our community, and by this I mean Inform and optimization community, is highly qualified for these types of this type of optimization model. But in addition to just the optimization models, companies will need to invest in visibility technology, ability to know where the inventory, ability to estimate better when the inventory will arrive, because accuracy of information can help improve supply chain response in case of a disruption.
Okay, thank you. The next question is about uncertainties in the estimation of TTS and or TTR, and more specifically, is it possible or how to incorporate the bullwhip effect and demand uncertainty in the TTS for upstream supply chain members?
Yeah. So there is a big difference between TTR and TTS. Let me highlight something that may be obvious to many of you. TTR is an input. We collect this data based on quarantine time, based on survey of our suppliers. Actually, in the case of Ford, Oleg and I ran a web survey of many of Ford suppliers in order to estimate effectively their time to recover. And then we came back to them with specific detailed question about the response. TTS is an output for the model, right? This is what the model is giving us. In order to determine TTS, we need a good estimate of customer demand. And so demand uncertainty is critical, but this is part of what we feed to the model to estimate how long we can match supply with demand under our current understanding of future customer demand in the market. That's why I emphasize that the second step in a recovery model is trying to estimate customer demand. This, for now, at that step, has nothing to do with TTS. I'm trying to estimate customer demand. I'm using statistical techniques, machine learning technique. I'm also using information about regions that recover, like different region in China. For example, I mentioned Hubei versus Hunan, South Korea. And in addition, I may want to complement this, and I realize not everybody can do this very quickly. I want to use pandemic modeling to help us better understand response of customers to the pandemic, given the social distancing and given the testing that are happening right now.
Okay, thank you. And there is a more specific question regarding TTS. For example, does TTS include inventories on hand? And what will happen if TTS depends on some different companies or facilities?
So TTS is inventory dependent, right? If you're looking at a tier 2 supplier, and this is a real case that I can report, you're looking at tier 2 suppliers, this tier 2 supplier is removed from the supply chain. I'm asking how long I can match supply with demand. If I have a lot of inventory of this component that I put somewhere in my supply chain, TTS is very long. So this is clearly time dependent, and it's also depends on the structure of the supply chain. It's also dependent on my forecast of customer demand. All of these are input to the model that I'm using to estimate time to survive. I want again to emphasize the optimization model that we developed that you can take advantage of if you want. There are a couple of papers, in fact, that my group at MIT has published on this concept that you can look at. All these technologies depend on the structure of the supply chain, require optimization, but we can do back of the envelope analysis to estimate what happened for specific companies. The optimization will perhaps give us a more precise estimate of time to survive. But right now, most companies can use back of the envelope. Just to be clear, when I published together with Pierre our piece at HBR, we just did back of the envelope analysis. And turns out it was accurate enough to predict what's happening now.
Okay, thank you. There are some questions, again, regarding supply chain resilience. People asking what can be something specific for small business, for aircraft manufacturing, for service industries, and for drug development industries.
So it's hard to answer without looking at the specific of the supply chain, but I suspect in the case of drug industry, the challenge is that a lot of the supply come from Asia, come from China. And if you cannot secure supply coming from China, it will be very hard to produce the products that you need in any production facilities in North America or Europe. This is one of the main reasons why we see shortages right now in that industry. Aerospace is different. Aerospace is all built on precise coordination of movement of components between different parts, so that at the end you assemble the airplane, the product that you need by bringing all the components together. Here you will need a more sophisticated model that coordinate activities across the different part of the supply chain.
Okay, next we have a general question. Can we expect a price increase for essential products?
So in my opinion, this is bound to happen. This is bound to happen. And I try to highlight this. Let me go to this slide. I try to highlight this in this slide in the third bullet. And there are two, in my opinion, reasons for that. The first reason, supply is limited. When there are shortages, we see this is supply and demand. We are going to see higher price. But this is not the only reason. The second reason, cost for companies is going to be higher. You need to expedite. You need to move a product from one part to another part. This implies impact on price. If you do a quick search on the internet, you will see examples of product report, of article reporting that for specific product, we see increase in price. Now, when I say increase in price, there are two places where the increase can happen. One is wholesale price goes up. This is happening. The second is consumer price. This sometimes happens. The question for the retailer is, do I transfer the increase in price that I see to my customers? I would say we see more increase in wholesale price. We see less in price to the end customers, but we still see some increase in price to end customers. And as this takes longer and companies need to expedite and their cost is going to increase, we will see more of this in the market.
Okay, thank you, David. Now it's 6 o'clock. Now let's answer the last question. In the long term, how will the supply chain structures and costs be affected by the pandemic? And how about some other factors like climate change?
So this is such an important question that I really don't have a good answer, except to say, until the last few years, we have seen a lot of focus on low-cost supply chain strategies, right? This is all about lean. This is all about outsourcing and offshoring. Companies have been very successful in that respect. Now, I think we are going to see, and we are starting to see a change in strategy to find the right balance. There is a trade-off here between low-cost supply chain strategies and resiliency in the supply chain. We are going to see companies starting to find what is the right trade-off between the two, and perhaps using analytics so that you find the right trade-off without necessarily increasing costs significantly. If you think about this trade-off, think about this as pushing the trade-off curve in a direction that allows you to improve on both resiliency without increasing your cost. And let me stop here and thank again Oleg, Marie, and Jason, and the entire Inform group for organizing this event.
Thank you.
Thank you, David.
Thank you.
Thank you, everybody.
Thank you. Have a good night. We will be putting out the link to the recording as soon as it is available, and we encourage you to share that. Thanks and have a wonderful evening.